Pre-Cal, welcome to week 4. We're starting another new topic. I know it's a lot of change, but we had several topics left and we just scratched the surface of conics and we're leaving it at that. Vectors goes back to using some trig, not today, but Thursday. And we will spend 2 weeks on vectors, so we'll go a little bit more detailed. Okay, so a vector is a line segment with both direction and magnitude, okay? So it looks like a ray that we used to have in geometry, but that's not the case. This beginning of it is called the tail, and the end of it's called the head, but it doesn't keep going. It stops right here. That just tells the direction that it starts here and goes in this direction and stops there. The magnitude is the length and the direction is the angle. So direction, like if I come back over here, the direction is the amount of turning from here to here, theta, and the magnitude is how long this is, okay? So it's just a directed line segment, okay? They have a beginning, which is the tail, and an end, which is the head. The arrow is used to show direction, and the arrow is where it ends, okay? Today we're going to focus on just component form. Component form, you use pointy brackets. It looks just like an ordered pair, behaves pretty much like an ordered pair, but notice these are pointy, okay? Do y'all see that? They're pointy brackets. So when you draw them, don't draw them smooth, draw them with a little bend in them. And it's how far it goes over horizontally, and then how far it goes up vertically. So if you had a vector, the idea is, if you had a vector like this, how far it goes horizontally and how far it goes vertically, okay? You can name a vector notice these little arrows. They're one-sided arrows. You can put a lowercase letter with that one-sided arrow on top. You can put the beginning letter and the end point. P and Q would be the points where it started and ended. Or you can just use a bold lowercase letter without anything above it. Okay, so those are the different options. So what I've drawn here is 4 different vectors, and each of them have a component form of 6, 5. The reason for that is they all go right 6 and up 5. So if I count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So this is 6 and 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 5. You get the idea. It doesn't really matter where a vector starts. They all have the same direction and the same magnitude. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay? So we could call that, since the beginning point is x and the end point is y, we could call it vector xy, or we can use the lowercase b. Okay, so here we go with some problems and examples. All right, now notice this one's, the arrow is in the opposite place, so that matters because direction is a big deal. So if we're going to name this vector 2 different ways, we can put just the lowercase letter c with a little side arrow. Or if we're going to name it, we have to be careful here. It starts at M and goes in the direction of D. So I'm going to put MD with the arrow going on top of the D because that's the way it goes. Now component form, you start at the beginning, the tail, M, and you want to do your horizontal distance. So I'm actually moving to the left, 1, 2, 3, 4, 5, 6. So my left movement, you always do the horizontal first, just like ordered pairs, is -6. And then I'm going down 1, 2, 3, 4, 5. So it's -6, -5 because it starts at M and ends at D. Draw an equivalent vector that starts at the origin. So I'm going to start at the origin. This would be where M would slide to. I have to go left 6. So 1, 2, 3, 4, 5, 6, and down 5. 1, 2, 3, 4, 5. And then my vector would look like that. You put an arrow at the end of it. Okay? All right. So what we're going to be doing is adding vectors. So when you add them on a graph, you add them tail to head. You always put the head of the tail of the second one on the head of the first one, and you just keep putting them tail to head, tail to head. Okay. The resultant is what you get when you add them. And it's a vector that is the result of adding or subtracting. And it starts at the original tail. I guess it says it up here. And ends at the final head. So if you look at my picture here, P is one vector starting at the origin and going up. Q is another vector that goes down from the head of P. And R is the resultant. So R would be called the resultant. That's what we resulted in. Let's write P in component form. Okay, so here, 1, 2, 3. I go over 3 horizontally and up 1, 2, 3, 4, 5, 6, 7, 8. So 3, 8 is P. And then Q starts here. I go horizontally to the right, so that's positive 1, 2, 3. And then I go down 1, 2, 3, 4. Down 4, so that's negative. And then I'm going to look at R. Okay, R starts at the origin and goes to here. So that's 1, 2, 3, 4, 5, 6 horizontally. And then up is 1, 2, 3, 4. Okay, now notice I could get this answer by just looking at this and this. Think about it. We added the two vectors together. So notice to add or subtract vectors, you can add or subtract them in component form and add the horizontal components. Horizontal components, 3 plus 3 is 6. And the vertical components, 8 plus negative 4 is 4. Show the problem above. We write it like this. So you would write it over here. Doesn't matter what color. So we'll go 3, 8, and underneath it you put a plus, and 3, negative 4, and then draw a line. And sometimes we'll put like a P, vector P, and then this was vector Q. You don't have to put that, but it's a plus, okay? And then we added them and got vector R, which was 6, 4. Okay, so even if we didn't have the picture, if we just had the component form, we could have done this method. Okay. Scalar multiplication is when the length of the vector is increased by a certain factor, or it could be decreased. I guess it doesn't have to be. This should say increased or decreased. Sorry about that. Okay. When doing scalar multiplication in component form, you just distribute the scalars. You just multiply it out to the horizontal and the vertical component. So if right here I've got A is negative 2, 5, B is 7, negative 4, and C is 6, 1. And I'm going to add A plus B to get R. So I'll go A, which is negative 2, 5, plus B, which is 7, negative 4, to get R, which is, and now I'm just going to add vertically, 5, 1. And that's it. I just added this horizontal component and the vertical component. Just added up and down. Okay, now I have minus. So it's going to be A, negative 2, 5, minus B, which is 7, negative 4. So now I'm subtracting. Negative 2 minus 7 is negative 9. This will give me the resultant, pointy brackets. 5 minus negative 4 is going to be positive 9. You could draw it out to see if that made sense, but these are the answers. Okay, now I've got scalar multiplication, so it's 2A plus 4B. So 2A is going to be 2 times A, which is negative 2, 5, which would equal negative 4, 10. And then I'm adding to that 4B, which would be 4 times B, which is 7, negative 4. 4 times 7 is 28, and 4 times 4 is negative 16. And if I'm adding those, my resultant is going to be negative 4 plus 28, which is 24, and 10 plus negative 16, which is negative 6. Okay, so we're distributing first and then adding. Okay, now I have 3. I'm going to add all 3. So I'm going to do A. Oops. I don't know what happened there. Do you? A, which is -2, 5. B, which is 7, -4. And C, which is 6, 1. And I'm going to add them all up to get my resultant. So -2 plus 7 plus 6 is 11. And 5 plus -4 plus 1 is 2. So there you have that.